Hello and welcome to a new video here at Underreach Math. Today we're gonna take a look at and then solve this problem here. And it's a really nice trigonometry problem, so if you want to solve it on your own, feel free to do that because I'm gonna solve it right now, so pause the video if that's the case. Let's dive in. Okay, so let's start with the problem. Well, how can we find the area of the shaded region? Well, these are circles with a midpoint, of course, and if we draw the midpoint right here, we can see that we can write a triangle inscribed in this figure. So write one of the sides here, one of the sides here, one here, and one here. And this gives us a triangle with some interesting properties that we can solve. And the three circles of radii 4, 5, and 6 are mutual tangent. Find the area of the shaded region. Well, we're gonna know this side here. We're gonna know that one. We're gonna know this one, this one, this one, this one, and this one. And the sum of these two are gonna be this side right here. Sum of these two are gonna be this side here, and so on. So that'll give us this triangle. Let me just switch colors. That'll give us this triangle with the sides. Well, this side is gonna be that radius, this radius here plus this radius here, and that'll just be 4 plus 5, and they'll equal 9. So this side here is gonna be 9. This side here is gonna be 5 plus 6, and that'll equal 11. And this side here is gonna equal 4 plus 6, and that'll equal 10. And if we have a triangle with three sides, that'll be the case SSS. Then we can use the law of cosines to find the different angles. And if we have these different angles, we'll be able to find the areas of the circular sectors that we can find here. So if we'll just take one circular sector here, one here, one here, and one here, the last one. And if we have the areas of these sectors, and then we have the area of the whole triangle, which we will solve later, then we'll be able to take the whole area, subtract the circular sectors, and then get the area of the shaded region in the middle. Okay, so before we find the different angles, I want to show you how we can find the area of this triangle. So if we have the area, if we want to find the area of this triangle right here, and we have the three different sides, then we can find the area by doing this. Area equals the square root of S, which equals half the perimeter, times S minus A, which is one of the sides, times S minus B, which is another side, and S minus C, which is S minus the last side. And in this case, S will equal the perimeter over 2, and that'll be 30, 9 plus 11 plus 10 over 2, and that'll equal 15. And that will give us that the area is the square root of 15, and then we can call this side A, this side B, and this side C. Or we'll just do it like A, B, and C here. So times S minus A will be 15 minus 9, and that will be 6, times 15 minus 11, which is 4, times 15 minus 10, which is 5, and that'll just give us the square root of 1800. So let's put that right here on the side, square root of 1800, and then we can just clean this up right here to get some more space. So we'll take this away, and we'll continue working on the problem. Okay, so let's find the area of, the angles of this triangle. Well, if we have the three different sides, we can find the angles by simply applying the law of cosines. And the law of cosines says that cosines, and that says that one of the sides a squared equals b squared plus c squared minus 2bc times the cosine of the angle A. And that's just, if we have this triangle here, we have side A, B, C, then the angles will be opposite their side lengths, and that will be capital letters, so we'll have it like this. So if we want to find cosine A, and we have this side, we'll just apply the law of cosines, and that will get something with the cosine of this angle right here. Okay, so now we've defined some of those things. Let's continue with the calculation, and applying that, this angle here is A, and that'll be 9 squared equals, and B is just 10, so 100 plus 121 minus 2, and B times C is just 11 times 10, and that's 110, and times 2 is 220, so 220 cosine of A. And simplifying by just adding this to both sides and subtracting this from both sides and then dividing by 220, we'll get that cosine of the angle A will equal, it'll equal 108, it will equal, this will just be 221, and minus 81 is going to equal, that'll just equal 140. So now we'll get cosine A equals 140 over 220, and if we write that in the simplest form, we'll get 7 over 11, because that equals, that's just 22 over, it's just 14 over 22, and that'll equal 140 over 220, which we started with. So now we can just take the arc cosine function of 7 over 11, and that'll give us that A equals arc cosine of 7 over 11. Okay, so that's one thing to remember. And then we'll just do the same things with the other sides, and the other angles. So we're gonna erase this and write the angle up to remember, and then we'll do the same things with the others. And one thing to remember is that the sum of the angles in a triangle is just 180 degrees, or pi radians. And when finding the area of a circular sector, you need to use theta in radians. So we'll use the last angle will equal pi minus the two other angles. So then we'll be able to write A equals our cosine, and you can write that as cosine to the minus 1 of 7/11. Okay, and the second angle, B, how are we going to do that? Well, in the same way. So B squared equals 10 squared, and that'll equal 100. So doing the same things as before, we'll get that 10 squared, which is 100, will just equal 81 plus 121 minus, let's see, we're finding the angle B, and that was A, that's side B, and then that will be angle B. Okay, so that will give us minus 2 times 9 times. Well, it's actually easier to call the side that is 11 B. It won't matter in the calculation. So we'll just make this side C and this side B. Okay, so B squared, which is, and then we'll have the side B right here, and this, we need to erase this B because that's not left. We're gonna have, this is angle B, and this will be angle C. So the side B squared is 11 squared is 121, will equal 81 plus 100 minus 2 times 9 times 10, and that'll just equal 2 times 90, and that'll be 1 minus 180. So, and that'll give us cosine of the angle B. And simplifying as we did before, we'll get that cosine B equals 181 minus 121. 21 is just going to be 60 over 180, as we had here. 180, and knowing your times tables, your multiplication tables, you get that this is just 1/3, because 6 times 3 is 18. 60 times 3 is 180. Okay, now we have this, so let's and then B, of course, will equal the arc cosine of 1/3, 1/3. Okay, so that's the last angle, and that's the second angle, and the last angle is just going to be pi minus these two, and that will give us that B equals our cosine of 1/3. C equals pi minus, and that'll just be minus A minus B. And the area of a circular sector is a formula that we're going to use now. And that's just that the area of the circular sector is 1/2 times the radius squared times the angle theta, when theta in rad, when theta is in radians. Okay, so we can now use these formulas and the fact that we have the radii of the different circles to find the areas. And then we just have to subtract those from the square root of 1800. Okay, so moving on, we have the first circle being of radius 4. so 4. So let's start with that one. And that angle was angle B, correct? So that'll give us that the area equals half times the radius squared, and the radius squared is 4 squared, and that'll equal 16. Half of that is 8, times the angle B in radians, and B was just our cosine of a third. 1/3. Okay, so this is important. Let's go ahead and write that up. A area 1 equal, and let's not confuse that with the angle, therefore sub 1. So a sub 1, area sub 1, will equal 8 cosine of 1/3. Okay, and now we're not gonna have to use this angle here because we've already found the area when it's necessary. Okay, and the second area is gonna be the area of the circular sector with the side 6 and angle A, because that's one of the angles that we have, and that will give us half of the radius squared, which is half of 6 squared. Half of 36 is 18. That'll give us 18 times cosine of the angle, because that's just the angle, and cosine of 7/11. Very good. Let's go ahead and write that up. So then we have that a sub 2 equals 18 cosine of 7/11, cosine of 7/11. Sorry, that's not a good 7. 7 right here, like that. Okay, the last one is going to be a bit trickier because we haven't found the angle just as easy, but it'll work out pretty easily as well. So now we're not going to need this angle either. Very good. And then we're gonna draw a new circle here. That will be angle C and radius 5, and it'll give us that that a sub 3 equals half of the radius squared, which is half of 25 squared, and that half of 5 squared, half of 25, and that'll equal 12.5. 12.5, and now we have to multiply this by c, and that's just pi minus a, and a was arc cosine of 7/11. 7/11 over 11 minus the arc cosine of the angle B, which was just arc cosine of 1/3. Okay, so A3 equals, well, that's just going to equal what we wrote, 12.5 times C. We'll just write C because this was a very long expression. And now we can erase these things here, the circle and this calculation. And now we just have one step left, really, and that is to find the whole area of the red region, and that will be the area of the whole triangle minus the areas of the circular sectors. And I'll draw a little figure to explain that in a pretty easy way. So erasing this, we'll have some more space left. Okay, so if we have a triangle here, right here, and then we have the circular sectors here, then we, here. We'd want to find this area here, and that'll just be the area of the whole triangle minus this, this, and this, and we found the area of the whole triangle here and the areas of these circular sectors. And then we'll just have the red one left, which was the red one we had from the beginning. So I hope that's understandable, and let's make the final calculations. So the area of the red region, wait, let me just erase this. Okay, so the area red, A sub r, equals the square root of 1,800 of 1,800 minus, and A1 was 8 r cosine of a third minus 18 arc cosine, well, just draw a line here, arc cosine of 7/11 minus, and that would be minus, we got C to be 12 point, we got A3 to be 12.5 times pi minus our cosine of 7/11 minus arc cosine of a third. And that is the final calculation. And using a calculator, of course, or GeoGebra or anything else, you'll get that the area in the middle is approximately, and remember that we used centimeters, it will approximately be 3.85 centimeters. 3.85 centimeters squared. So if you got that, well done. If you didn't get that, maybe that because you used degrees or something. I hope this video was helpful. It was a really cool problem, and I really liked sharing it with you. So thanks for watching. Feel free to leave a like or subscribe. Bye bye.